morning, students. We shall continue from where we stopped in our last class. We are still on probability. Let's quickly do a review of what we learned in the last class. We talked about the basic terms or language of probability: experiment, outcome, the sample space, event in the sample space, as well as randomness or equally likely. Let me just pick one: randomness or equally likely. I said in the last I asked that what does it mean to select or to choose at random. For example, if you have four balls, four different colors of balls that are the same size, it simply means that each outcome is assumed to occur as often as any other outcome. So the outcomes are equally likely. Each outcome is assumed to occur as often as any other outcome. Okay? And further, we looked at the mathematical notion or definition of probability. That the probability of an event E is the number of outcomes in the event E over the number of outcomes in the sample space S. Further, we also looked at the scale or range of probability alongside with types of event. Now, the probability of an event lies between these two numbers, 0 and 1. Both numbers are inclusive. Both inclusive. In mathematics, we write like this: limits or values, we write, or intervals. We write this. Both are close on both ends. Okay? So we talk about certain events, likely events, even chance events, unlikely events, and impossible event. Okay? Later we look at the expectation E of an event. We define that as the product of the number of trials and the probability that that event will occur in any one trial or in any single trial. This is the number of trials. Okay, and times the probability that that event will occur in any one trial. So quickly, we will take some examples. Let's consider some examples. Example 1. What is the probability that an integer selected from the set of integers 20, 21 up to 30 is a prime number? Okay, so solution: let S is the sample space. Don't forget, S stands for the sample space. So for the sample space, we have the integers 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay? We are interested in the event prime number, selecting a prime number. Let the event E is equals to prime numbers. Okay? So, and the prime numbers in the sample space are prime numbers. We have 23, we have 29. Okay? equals 2. So, the number of outcomes in the sample space, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the number of outcomes in the event A, prime numbers, 2. So, it implies that the probability of E equals to number of E over number of X, which is 2 over 11. That is the answer. So the second one, very quickly. A box contains 5 red and k blue balls. A ball is selected at random from the box. If the probability of selecting a blue ball is 2 over 3, find the value of k. Find the value. Let me use this part of the board. Find the value of k. Solution 2. How many red balls do we have? Number of red balls, 5. Number of blue balls, k. Then the number of sample space, k plus 5, or 5 plus k. The probability, if the probability of selecting a blue ball is 2 over 3, probability of selecting a blue ball is given. Probability of selecting a blue ball, probability of a blue ball is 2 over 3. Okay? Find the value of k. The probability of selecting a blue ball is found using the formula. Probability of a blue ball is number of blue balls over number of sample space is equals to 2 over 3. That is, number of blue balls, k, number of sample space, k plus 5 is equals to 2 over 3. If you cross multiply, what are we going to get? Cross multiply, we have 3k, 3 times k, 3k is equals to 2 into k plus 5. 3k to 2k plus 10. K is equals to 10. Okay, so that is the solution. Okay, the next example. Example 3. Let P be a probability function on set S, where S, the sample space, consists of the outcomes A1, A2, A3, A4. Find the probability of A1 given the probabilities of A2, A3, A4. Okay? So how do we do that? The probability of the sample space, probability of the sample space is 1, or the sum of all probabilities is 1. And the that is sum of all probabilities, you know, I from 1 to n. Okay? Or the probability of the sample space, probability of the sample space is equals to 1. Okay? In other words, if we add up the probabilities of A1, A2, A3, A4, it will give us 1. So that implies probability of A1 plus probability of A2 plus probability of A3 plus probability of A4 is equals to 1. So probability of A1 plus probability of A2 is given 1 over 2 plus probability of A3 1 over 6, probability of A4 1 over 5 is equals to 1. So probability of A1 plus the LCM in this case is 30. is equal to 1. Probability of A1 plus, this is 20, 26 over 30 is equals to 1. So, therefore, probability of A1 is equal, you can reduce this to 13 over 15 if you like. 13 over 15. 13 over 15. So probability of A1 is 1 minus 13 over 15, which is 2 over 15. The next example, very quickly, the last one. It is known from past records that 8% of modern plastic items are defective. Determine the probability that any one item is defective. 2. Acceptable. 3. The number of acceptable items likely to be found in a sample batch of 4,500. Okay, so let's start. I'm going to use a different notation now. Solution. Let A, I use A, let the event A is equals to defective plastic items. Okay? So the first part of the question, A, Roman figure 1. So the probability of probability that any one item is defective is given. Okay? That is 8%. 8%, which is the same thing as 8 over 100. Or we divide this. Okay? Anyhow, this is 0.08, which is the same thing as 2 over 25. 2 over 25. 0.08. Same thing as 2 over 25. So that answers the first part of question A, Roman figure 1. Roman figure 2. The probability that any one item is acceptable. Don't forget explanation on complementary events. Okay, that the sum of the probabilities of complementary event is 1. Okay, the probability of an event E plus the probability of its complement E prime is equals to 1. That is, the events E and E1 are complementary events. Okay, so the second part, the probability that any one item is acceptable complementary to this, that is the probability of A prime. That will be 1 minus probability of A. So 1 minus 0.08, which is the same thing as what? 0.02. I mean 0.02. 0.08 is that 10, 9, sorry, 0.12. 0.12. Or if you like in fraction, as a fraction, that would be 23 over 25. 0.12. 0.92. Oh. 0.92 or 23 over 25. Okay? So, the next aspect, the number of acceptable items likely to be found in a sample batch of 4,500. That is the expectation. Okay, the expectation, that is B part, the expectation E is equals to the number of trials times probability. We are interested in acceptable items. So this will be 4,500 times 23 over 25. Or 4,500 times 0.92. This is calculator work. Okay? 5 here, 5. 5 here, 9, 0, 0. 5 here, 1. 5 here, 1. When down 4, 8, 0. 180 times 23. 180 times 23 should give 4,140 items. This is an example on application of industrial quality control. Okay, so out of the 4,500 plastic items produced, 4,140 meet the required standard. They are acceptable items, no defect. Okay, so in another question, you may be required to find the number of defective items. So in that case, it will be the number of trials, that is number of items produced, and in this case, times the probability that any one item is defective. In that case, it will be times 0.08. Okay, so we have come to the end of the lesson, and you can now ask your questions. Thank you.